Hello and welcome to the 9th episode of Making Cell, a series of videos where I record myself designing and implementing a programming language and environment called Cell. So this is the 9th episode, so if you want to understand what this is about, you can just jump to the first video, or you can go here to github.com/cell. I'm going to paste that link in the description of the video. So let's just keep on going. So the last video, which was a few days ago, was about bootstrapping an initial version of Cell that implements two calls, which are get, which is basically you don't have to put anything after the add. Let's say if you want to get foo, you would do something like add foo, and if you want to put something in foo, you would do something like put foo bar. And the idea is to implement this in JavaScript in the browser, so we can get some code running. So I've been doing a bit of thinking and reading about what bootstrapping is, and I basically, I'm just understanding it that when you're bootstrapping something, it's like you want the system that you're building to be already processing your calls, and at the same time you want that system to be running in a computer, which basically means that system has to make calls that already exist. Otherwise it cannot run on a computer. So it's that double nature. It's basically supporting itself through making calls to something else, and that's exactly what we're doing here. If we look at the code of last episode, we are basically just writing JavaScript, really, not Cell, but we're writing a JavaScript that is going to allow us to make Cell calls and just get basically some stuff going on. So with enough calls, we might actually write less and less JavaScript and just stay in Cell. So it's going to be interesting to see how that comes about. And the other thing I realized like an hour or two ago is that I just need to keep on going and get this thing working for now. And then when we see something on screen, we will find a better sense of direction or what to do next. But we need to see it run. I need to see it running. So we had a bunch of code from that we had built over the last episodes. So I'm just gonna copy pretty much the whole lot. So let's just do that. So we have a receive function which receives a call, and then it just sends it to get and put. Then the parse function that processes the message that comes inside the call, and then the actual get and the put. So I'm trying to remember where I left it last time. Yes, we left it in a place that we were not doing the proper logic in get when we had multiple lines. So we came up with an algorithm here to implement it properly. The interesting thing about what we're doing is that basically every call we get is text. I said this in the last episode, but I'm still thinking about it and I like it, which is I get some text in a call. Then I update possibly the state that is inside Cell, which is just basically text in local storage. And then the response itself is also there. It's inside the state. And that's pretty cool because it's just text, text, text. But it's not a text in, text out. There's also a change inside. I like the shape of that. I think it's a shape that you can use in many other places. And where was I trying to get with this? Yeah, just today I was thinking about, I was basically working at my day job and working on a system that had we're basically doing image recognition and then running that data through an LLM. So a lot of these operations are take a few seconds each, and they're chained, and some of them are in parallel because you have like multiple things going on. So even to reproduce something that you fully control requires to put, let's say, a lot of state somewhere where you cannot really access it. I mean, you can only access it through the path that you already set for yourself. But once you're, let's say, in the middle of things, and let's say you have these files that are parsed, and then this structure is put into memory in JavaScript, because I'm using JavaScript for it, then if, let's say, something breaks or that something doesn't go according to plan, the system crashes or stops or returns an error, and you're done. And then I have to basically do the whole thing again with the change, with the log or with something else to get to that point. I know that if I use a debugger, I would kind of get that possibility of holding the system a bit frozen, but basically you can just pause it. But to go forward and backwards, you cannot really do that. And you spend a lot of time trying to do this type of thing. So I was thinking that if the state of my system was fully textual and let's say fully first class, like first class state, then I wouldn't have that issue. I could basically, if things stop because of an error, I would just not lose the state. I could still like work from that intermediate state that I had there and just make a change, and then the system would keep on going a bit further until it found the next error or until it was done. So that's really the hope that is burning in me today in Cell, to get to a system where, because the state is like right there, first class, it's just text, you can actually operate on, let's say, state itself directly. And then the debugging process, especially when there's slow operations there, can be much faster. Not even the debugging process, the iterative process of building software. So now I have to modify this. Now I really need to code. So the idea is we need to find a line. Yeah, we basically need to find the line in the case of the get that matches something. So let's say we have this thing. Let's just go with a canonical example. Canonical. I'm using the word canonical far too eagerly. So if I do this, is, let's say this is the entire state, and I do foo yip, what I want to get is what? I'm gonna get a 2. That's what I want. Actually, let's make this a bit, yes. And if I do, I want foo, then it's just gonna give me bar yip, so that way. So yeah, this is what I want. It's pretty clear. So we go again with the sequence, and it will be fun eventually to write this in Cell itself. So I just go split the data space in new lines. So for each line, if, by the way, I'm using for each instead of map simply because I'm not returning anything, although it would be the same if I did a map. But a former colleague taught me that distinction for readability. Thank you, Ian. So find the line that starts with the first element of the message. So it's not just the first element. It's like we have to basically keep some sort of pointer or like track of how many elements in the message which we have already matched until we're out. That's what we want. So we cannot just do this escapeForRegex, the entire thing, and just join the message. This is all wrong. It's wrong. It was just too simplistic. It was fine, but I wanted this version already working. So I cannot just work with a single line data space. Well, not single line, but where I'm gonna have nested structures. I cannot work with that. So we need something better. So we're going to do it like this. So we have the message. So we can have a variable called matched message, and the message, we know it's just a flat array, so we can just do, I hesitate to use anything else than ES5 JavaScript. I still fantasize with running this in Internet Explorer 6 just because everyone else is doing the opposite. So let's just be fucking bullheaded and avoid it. So let's do it. Yeah, this is when nobody wants to collaborate with me in open source. This is because of things like this. So we're just gonna do a copy by doing a map, and this is a shallow copy, but because the elements of the message are text and number, they're actually not even numbers, right? They're text. I'm gonna get in trouble about that later, but for now we can ignore it. Yeah, I'm definitely gonna be in trouble, but it's okay, we'll fix it. We just need to add more test cases that show the problem, and then the code that fixes it, and then refactor the system. Actually, factor the system. I'm not going to say refactor anymore because it's factoring. That's the term. It comes from Forth. It was later like taken by Martin Fowler and in terms of refactor. But the idea of factoring is that you take the elements that are similar in a solution and then abstract them away, like taking away a factor from a bigger number. So that's a good word, factor. That's the one I'm going to use. I don't know if I'm ranting because I'm ranting, if I feel ranty, or if I'm ranting because I'm procrastinating on writing code. I wonder which one it is. So I have the matched message. So I copied the message because I want to basically lop off parts of the message. Do I want to do that, or do I want just to keep track of the index? Honestly, I don't need to do this shit. Sorry, I am. Let's just keep a pointer. Matched elements. And we start at 0. We have 0 matched elements. So we don't need the match found either. We're going to be pretty... Or do we? Yeah, we need it. Sorry, I think we do. Okay, let's just do it. So this thing will get up to the length of message, or not, in which case we will never return anything. We'll just return an empty text. So we're splitting the data space, and we have a case, which is, we have the case where if matched elements equals 0, basically we haven't started the match yet, we check if this thing is relevant, basically. If there's a match between this and the first element of the message, and again, this has to be a string, and let me just look at the parse message. I'm parsing a message. I'm just returning a slice. Yeah, message.trim split by spaces. So this started as text, so it always has to be text. Then at some point we can just do something like to do interpret numbers as numbers. Actually, no, you know what? I'm not going to do any to-dos. We're going to live in the now because we can. So where was I? Yes. So yeah, I was thinking forever to do this thing. That's what I was doing. So it's okay. So if there's a match here, we basically do we increment. Actually, it's not per line. I need to iterate. I need to take the line, split it in by spaces as well. Assuming everything, I'm assuming I don't have any double quotes anywhere because that screws up everything. So I kind of need to parse the line, really. I wonder, can I use parse here too? Yeah. I mean, there's no lines with message with length of 0. But they start with add. Here I'm expecting the add. No, it doesn't work. So this is this is my lexer. This is funny. Check it out. A one-line lexer. Oh man, I hope I'm pissing off someone. Not because I like to piss people off, but I just like, yeah, maybe I like pissing people off a little bit. So so I trim it and split it. So that's what I need to do that with the line, of course. So I'm getting a line, but I'm trimming it. This is problematic because if I start with a space, okay, let's just assume for now we're starting with the line that has like this line. Where is it? Here. Let me just put this at the top so I'll stop scrolling. Like this starts with text at the left. So let's just start there for now. We can just cover the other case later. And by later I mean in 2 minutes. So yeah, I need to basically compare two lists of texts. That's it. So it will be line, trim, but not even trim, split. Oh yeah, I do need to trim it because I can just get, let's say for the second one, I just get rid of this and it's just yip and 2. So yeah, it's fine because I already match foo if I am already, let's say, in that part. So yeah, line equals line split. See, this is a perfect instance of why I think it's perfectly okay to have mutability. Line here comes as text. I have no further use for line as text for now. So I want to redefine line as a list of texts. That's perfectly fine. That's the way to make it simple. If I had to create like something like a list from line or elements in line or whatever, that's just noise. So that's why I will never use something that doesn't allow mutability, because of that. So I have the line there, I'm splitting it. So the message, I of course don't have to split it here. Yeah, I'm not doing stupid shit here. This I just copied. So yeah, sorry, I'm quite slow. I apologize. Maybe I should record not at night. I trim and I split. Good. Then I do something like this. I need to iterate the elements of line. I need to iterate the elements of line and see and stop at the first mismatch. I do not want to use loops that are not functional. So what do I do? Normally I would use my library here, which I can use. Let's just use my library here because I'm going to use anyway my front-end framework. Was I using my library for anything else? I have a set of libraries that I use for everything in JavaScript, but here I was trying to stick to a purely non-library ES5. Nah, you know what? Let's just keep it pure. So I just need to iterate things. So let's just do it. I need to look it up. This is why I like to use my library because I already know what to use. iterate and stop functional loop.js. Yeah. No, because yeah, break is the go-to of loops and should be avoided. Yeah. Yeah. No, I'm not going to go there. I'm going to use my library. I got tired of it. Function is stop, and I'm going to stop on an absence of a match. I'm going to iterate the line. I'm just going to put a value here and a key. So I'm going to return that the value, actually if the value is equal to message, the kth element of the message, then I return true. Actually, we can do it the other way around. If the value is not equal to the message, then return false. Otherwise, keep on going and increment matched elements because we have a match. So that's how it works. Yeah. So it's going to do that. So it's going to be matching how many elements that line has to destroy that matches the elements in your message. Cancel them out. Yeah. Keep on going through the lines, finding something that matches a bunch of spaces. Yeah, that we don't even need to do because we have the trim. Because we're keeping track of how much. No, but then we have an issue there. Yeah, we need some sort of reset when we find something that... yeah, the question is how much we want to pull out of here. Like, at what moment do we stop returning stuff in terms of lines? That's what we need. Yeah, we need that stop. I'm thinking about it, but this is good. I am sure this is okay. Because I only started matching mode when if matched elements equals message length, it means we found the what we're looking for. Match found equals true. And if this is the first line for which we found a match, like let's say you're getting foo, I have found foo, then this line is relevant and the next line is relevant. For how much is the line going to be relevant? And it's like, as long as the amount of spaces in each line is equal to the length of the matched messages, so actually the length of the message would be joined by a space plus 1. The moment that the amount of white space is less than that, the line stops being relevant. If match found, output push, line. So I'm pushing that. I'm just going with the case where, like, say, I'm always doing the processing on the line, and then I find, are there any match elements? Yeah, okay. If so, just add them up. If there's match elements, you put it to true, and then if we found a match, do this. So how now do we check that we're done? Yeah, we kind of need the function that stops at some point, so it's more clear that we are done. So if necessary, we can always replace this by native counterparts. So false function line, this is the exact same thing. Yeah. If there's no match, this is still 0. Then this doesn't get done. This doesn't get matched. It will be interesting to see, even if I remove this case, if this will still work. Yes, it would, because it would be true, and then would keep on going. Yeah, I think it would even work. We will try it later. See if we can remove this. And then, now that we enter the case, if match found, output push line. Actually, before we push the line, let's just check if the amount of space. But we cannot check the amount of space if if we just set that flag. If we just set that flag, there's not going to be that amount of space there. We're in the line. In this case, yeah, the order of things needs to be different. Like the first line where we find the match cannot behave like the other ones necessarily. The logic is going to be different. So we can do something like this. If you already found a match, we go in the... We try to see if we can stop finding the match, or we are still okay. So then we can do the indent is this one. Yeah. The indent is you take the message length plus plus 1, the message length plus 1. If I will have foo, because yeah, see, I said I didn't need the line anymore as an array. Wait, here the line is still no, never mind. The message is text. So here I'm thinking of the message as text. So I just have to do message join. So I just join it by spaces, and then the length plus 1 because it's the last space, and then I just return that amount of spaces. And if there's a match, we push this, else we just set match found. Actually, we can just return false, so we can just be done with it, and this will stop the loop. Well, we need to return here. So this is the case where match is not found. I'm going to make it more explicit here, in which case I really don't need returns here. what do we need here to signal the end? I wonder how it's gonna look when I actually do stuff like this in cell, because I can see the sharp edges of what I'm doing here, not to mention the amount of syntax there is, and I wonder how it's gonna be on the other side. So I trim, I do the match element things, and let's say I just found the line, the first line that matches. What I need to do is what do I need to do? I need to return the entire line. I will do the removal of what comes out later. So I just need to do this. This is enough. That is enough. There's nothing else to this, really. Now that I have this, I have the output. So the first line of the output is gonna have a lot of things that I don't need, which is when you're asking for foo, you want to basically remove the entire length of the original message plus a space or its equivalent in characters in the first line, and just give me that. Could we actually just do it in the line here so we don't have to process again everything? I think we can, because here we're already replacing the indent. Yeah, man, I'm slow. We can just do this. Look, we can just do output push. This if we just found it, we just do the message replace new RegExp message join by space, yep, and replace it by nothing, by an empty, not nothing, sorry, an empty text, and that's all she wrote. I'm gonna just return this joined by new lines, and that's it. Look at that, only, yeah, it's 35 lines of code. Could be, actually, let's see if we could remove this. If the message has no length, I go through the data space. So if there's no match, I trim the line. I don't know what's going to happen with the line, but basically there's message k is always undefined, so this is always false, but then match elements equals to 0, so I find a match and I replace whatever came in the message, which is, if you join an empty, yes, you get an empty text, so you're replacing nothing with nothing. Interesting. But then that means that the line is intact, and then you just push it, and that works. And then if you go here, see how I'm just running the code in my head. I'm not going to have to do this with cell. I'm not going to have to do it. I will just be able to see the partial results of what I'm defining through just making an execution of it just below it or above it, and see how it behaves. I can't wait. I'm very excited for that. And then if it's 0, I found a match. So the indent is, the message has length 0, I join it, is still 0, plus 1, I fill it so I have 1 space, and I'm matching things that have 1 space. In this case, it would not work, because I'm just having this little pesky space, and so I wouldn't get the further lines because of that pesky space, and I will have to add a conditional here which is much dirtier than just letting this here. Good try, because it did work for this part, not just for, but not for this one. So what do we do with the put? I'm, I guess, hell-bent in not running anything tonight. Am I going to hit 10 episodes without running anything? That has to be some sort of record, a bad record, unlike the one I'm listening to right now. So I need to sort insertions alphabetically. Oh, that's going to be painful. This is the put. This is the one that modifies the data space. Yeah. Implement find, which gives you the line number at which your data is. This is tricky. I wonder, could I just test get? I just want to test get. Like, wow, look at that blank slate. Because I moved all the old code that I had before the video. So I have a blank slate here. So let's just draw something, anything. So what was the way to do it? Let's just define a view. That says and then we're just gonna mount it. This comes from this library called Gatov, which is loaded here in this HTML. So and we can be a bit more. It's globally bounded, so that's why it's already accessible. But I just did this as a way to clarify where it's coming from. I'm just mounting. Is it body view? Yeah, I think it's where and then what. So if I just do this, okay, we're onto something here. So we could just put a what I call responders. I don't want this to become a tutorial on how to use this framework, which is here. I'll just add a link here somewhere at the top. So I use this framework in my project. It works very well, but I don't think anybody uses it, or perhaps they do, but they never told me. There was one person that was using it a few years ago, and we had a very good correspondence. Hello, Andrew, if you're watching this. But besides him, I don't know of anyone else. So here I'm just going to define, let's say, a couple of events, which are going to be like for, we have receive, we have parse. Yeah. We could actually just do this here. I think we can just copy stuff and just have to have some sort of working thingy set up. What do I call it? Everything cell. So what is it? Main functions. So receive, get, yeah, and then we have the what I call responders in Gatov, which are basically things that respond to events. And if I use my current terminology, they wouldn't be called responders, so it would just be called calls. Really, the definitions of the calls. I still am tripping a bit because I'm still not distinguishing so clearly between making a call and receiving a call. I mean, perhaps if you're focusing on the noun, then it's the same thing. I don't know. I need to progress further. But here I want something like get from cell, and this would basically do something like Actually, before I define anything, let's just try to use it, right? So I would start by, we can have an initialize event that does something like something like this. If the data space is null, local storage set item cell, and I would just set it to, let's say, this example I had here with foo and this stuff. Why not? Let's add something else which can already cover a couple of cases. Nope, like this. Yeah, I know I broke the indentations. Thanks for letting me know. Appreciate it. Okay, this gets joined by a new line. So when you initialize, you do that, and here we need to be call. Let me do it like this. Oh, so the space is equal to this. Everything's fine. Let me just change the music here. I don't know what this is, but that's not what I wanted. Yeah, I want another record. Yep. Yep. So I have that. Then I just set the local storage set item cell to the space. I cannot do this because I need to do two things here. I need to do that, and then I just do. I'm going to set within the state of Gatov. I'm just going to set the data space to data space. That's it, and then we're just going to have something like this cell, and then I need to actually make this a reactive view that depends on the data space, and I get the data space. Yeah, I think this could be trimmed in cell. So text area, I cannot ever remember. Text area, I think it's just content, right? So I'm just gonna do it like this, and we can just do a pre. I don't know, we have to start somewhere. We're going to draw something on the screen. Boom, look at that blowing up. What is your problem? Your problem is that, yes, that I'm not returning anything, of course. Yeah, there, fixed it, right? No. Oh yeah, I have to return a single thing. In Gatov, I have a one-to-one mapping between a reactive view and a top-level element for that view. So I'm just gonna wrap it into this because why not? Okay, where is my pre? Nowhere. I don't believe it. Yeah, it's empty. Why is it empty? Because I didn't initialize. Haha. Okay, good. Boom. I wasn't expecting that. What's that hello? Ah, because I had stuff already there. So if I just say, if I'm just, okay. Now, okay, we're looking at something. I need to stop now. But we have something in screen. I'm so tempted now. Let's just keep on going a little bit more. How could I get something? I can. This doesn't work. Ah, yeah, it works because I'm working at the top level. Nice. I love it. So if I do get foo, nothing. That's weird. Ah, because I cannot just call get. I need to call parse, dude. And then parse is doing more than parse. It's just sending everything. Ah, I couldn't go receive. Sorry. Receive. Okay. Blew up. Line 15. Yeah. Next episode we debug. Thanks for joining. Bye bye.